we have an expression that we're trying to show as prime, not prime, for all non-negative. Okay, non-negative. That's what the superscript greater than or equal to 0, of course, means non-negative. So I'll just write non-neg, abbreviated, non-negative integers. Now the first non-negative integer is 0, right? And so let's just take a look at what we have going on right here. And again, we're trying to establish this four-termed expression is not a prime number. Another way of saying that, we're trying to show it's composite. Okay, and that means it has at least one divisor strictly between 1 and the number. That's the definition of composite. So if you look at n equals 0, you get a trivial 4, right? 6 to the 0 is 1, 6 to the 0 is, this all adds up to 4, which is clearly not a prime number because it has a divisor between 1 and 4, namely 2. Okay, now let's look at n equals 1. Now I won't even try to do this one all the way out, but I'll just write it down. That would give you 6 to the 7th plus 6 squared, right? Plus 6 plus 1. Now, I believe this particular number, whatever it is divisible by 7. So it's not prime. I haven't showed you that, and I'm not going to. I don't want to take time. I want to show you the structure of this proof. But anyway, the numbers start getting too big, you know, I mean, you to write down even once you even get to n equals 2. Okay, but we want to show in a non-computational way that this expression is never a prime number for all non-negative integers. Okay, and of course for negative integers it wouldn't make any sense because we would be in the domain of the rational numbers. Now, this observation isn't a requirement, but it's a good thing that this is odd. Otherwise, we would have nothing to do. If this were even, it's obviously not going to be a prime number, right, unless it's equal to 2, which it's not. Okay, so it is odd. And a way to rewrite this that gives us some ideas right here is to write this as 6 to the n. This is the property of exponents that everybody learned in high school, we think. 6 to the n raised to the 7th power. You have 7n, but this just means you have 7 copies of n, essentially. And then right here you would have 6 to the n quantity squared. And then just 6 to the n, right? Plus 1. Now why do we go through this step here? Well, notice this has the structure of x to the 7th plus x squared plus x plus 1, okay? So we got the indeterminate x, and we're saying to ourselves, does this possibly factor? Well, for this to be true, it must factor, and the factorization is given by this. Now, I'll just give you a few hints on how you can discover this. Notice that x cubed times x to the 4th gives you x to the 7th. But now, when you multiply x cubed times negative x cubed, you get minus x to the 6th. But right here, you have a plus x to the 6th. So this creates kind of a telescoping condition. All right, not quite exactly telescoping, but you get a lot of the terms being offset. Now, if that's not good enough for you, one way to think about this is just to put a minus x cubed right here and a plus x cubed. And then you can use the binomial expansion for the 4th power, and you can actually get this. Now, some of you may have already noticed this isn't completely factored. You can factor this into x squared plus 1 times x plus 1, but this is all we need to show that it's not prime, so there's no need to factor it any further. Okay, so whoops, y'all, this is supposed to be x cubed. Sorry, my bad. So this is the standard mathematical trick of adding 0 in a clever way. All right, because you can see how you can factor an x to the 3rd out of this, and you get x to the 4th minus 1, which is a known factoring result. And then that's you can kind of believe this a little bit more once you look at this clever little trick right here. But in any event, we've essentially finished the proof, because if we take x equal to 6 to the n, we can see we have exactly this expression that has two factors, and both of these factors are greater than or equal to 2, much greater, right? Both of them for all values of n, right? 6 to the n. You would just have 1 here at the worst possible case. If n were 0, you would have 1, so this would be 1 plus 1 plus 1 plus 1, right? You already got something. So you can, it's very easy to believe. So with this factorization and with this substitution, okay, we've shown that this is a composite expression. In words, this is not prime. And I think not prime and composite are synonymous. But maybe some you know, 1, they've always argued about 1 and 2 a little bit, I think. But anyway, this is not prime based on this substitution and then this factorization result. Okay, that's all I have.